In the beginning of the 19th century, our scientists ventured and made the impossible possible, giving birth to the idea that matter consists of indivisibly small particles called atoms. An atom that no one has seen was so clear in the brightest mind. An atom that is too small but so big in imaginative minds. I am Jemwel Dela Paz, your lead investigator in this case 3.3 entitled Atommodeling. Let me introduce to you to the 5 candidates who accepted the challenge in atom modeling in this new episode of How to Be a Scientist, a journey where science is the key. Welcome to this year's atom modeling. This modeling aims to determine the number of protons, electrons, and neutrons in a particular atom. Specifically, you are expected to discuss and understand the historical background of the atom and its subatomic particles, and describe the atom and its subatomic particles. The proponents of these models are the greatest and the brightest in their own era. John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr, Schrödinger. Ladies and gentlemen, please give them a round of applause. Before we proceed to the main event, let me present to you these notes from our scientists. Without further ado, this year's atom modeling, model number 1. Dalton's atomic model. It is the very first complete attempt to describe the matter in terms of atoms and their properties. This model is also known as the billiard ball model. It is hard, dense, a ball-like structure like a billiard ball. The concept of atomic nucleus and the electrons were unknown during this time. Proponent. This model of atom is proposed by no other than John Dalton, an English chemist. He suggested that each chemical element consists of its own unique kind of atom. He is also the mind behind Dalton's atomic theory. If you ask Dalton to draw his diagram, he would simply draw a circle. As simple as this, but made the scientific world rise from the abyss. Dalton's atomic model. Model number 2. J.J. Thomson's atomic model. This atomic model looks like a plum pudding or a raisin bread. This model was proposed soon after the discovery of electrons in 1904, but before the discovery of the atomic nucleus. It had negatively charged particles, the raisins, embedded within and randomly in the cloud of positively charged spheres, the bread. It tries to explain that electrons are negatively charged particles and that atoms have no net electric charge. The positively charged spheres exerts the force on the negatively charged electrons. The direction of the net force on the negatively charged electrons due to the positively charged sphere is towards the center of the sphere. These negatively charged electrons repel each other and form the shell. This mouth-watering model was proposed by J.J. Thomson, an English physicist. He discovered the electron in year 1987 using a cathode ray tube. Here are the limitations of J.J. Thomson's atomic model, the plum pudding model. The whole atom was electrically neutral, but Thomson's atomic model failed to explain Rutherford's alpha particles scattering experiment, in which most of the fast-moving alpha particles went through the gold foil straight away. These were some of the drawbacks of Thomson's model of an atom, which failed to explain the atom's stability and the scattering experiment of Rutherford. So the next time you eat bread, look for the raisins and see how random they have been. Thomson's atomic model. Model number 3. Rutherford's atomic model. The present-day understanding of atoms is based on the nuclear model of an atom proposed and explained by Rutherford. This model is an improved version of the plum pudding model. This is mostly made up of space with electrons orbiting in specific paths around a fixed, positively charged nucleus. The presence of the nucleus in this atomic model is its most prominent characteristics based on the result of the alpha scattering experiment. Rutherford concluded that major space in an atom is empty based on his observation during his experiment. As a result, the majority of an atom must be empty. Proponent: Ernest Rutherford was a New Zealand-born physicist in 1911. The Rutherford atomic theory has defined the atom as tiny, dense, positively charged core called a nucleus, which is surrounded by the negatively charged called electrons. Rutherford's atomic model is limitation. Certain things could not be explained by Rutherford's experiment. They are as follows. Rutherford's model was unable to explain the atomic stability. According to Rutherford's postulate, electrons revolve at a very high speed in a fixed orbit around an atom's nucleus. Maxwell, on the other hand, explained that accelerated charged particles emit electromagnetic radiations. As a result, electrons revolving around the nucleus emit electromagnetic radiation too. Rutherford's theory was lacking in detail because it did not address the arrangement of electrons in the orbit. One of the major flaws of the Rutherford's atomic model was this. Remember that even atoms were improved through generations. Rutherford's atomic model. Model number 4. Bohr's atomic model, a planetary model of an atom. It resembles the solar system. The nucleus, which is found inside the center of an atom, looks like the sun, which is also found at the center of our solar system. Electrons, which are revolving around the nucleus, are like planets which are also revolving around the sun. It is composed of small nucleus surrounded by negatively charged electrons moving around the nucleus in specific orbit. This model explains that electrons are moving in fixed orbitals or shells and not anywhere in between, unlike the plum pudding model. It also explains that each orbit or shell has a fixed energy. The electrons located away from the nucleus have more energy and electrons closer to the nucleus have less energy. Proponent: Niels Bohr. This atomic model was proposed by Niels Bohr in 1915. He modified Rutherford's atomic model. Here are the limitations of Bohr's atomic model. Bohr's atomic model failed to explain the Zeeman effect of magnetic field on the spectra of atom. It also failed to explain the Stark effect of electric field on the spectra of atoms. It also violated the Heisenberg's uncertainty principle. Seeing the smallest size of our solar system is amazing, knowing that this was made for the living. Bohr's atomic model. Model number 5. Schrödinger's atomic model. This is the quantum mechanical atomic model. This powerful atomic model assumes that the electron is a wave that tries to describe the regions in space or orbitals where electrons are most likely to be found. The inspiration of this atomic model was Bohr's atomic model. This model was used to calculate mathematical equation that discovered the electron occurring in different places or in a certain position. It doesn't specifically locate the place or movement of the path that the electrons in an atom go, rather than giving the statistics and probability of an electron being at a certain position at a certain time. This model was too abstract and the mathematics is unfamiliar. That's why some scientists like Werner Heisenberg questioned his model. Heisenberg developed the uncertainty principle that explains the position and the velocity of an object cannot be measured exactly at the same time. This modern atomic model is based on quantum mechanics, a fundamental theory in physics that explains the physical properties of nature in the scale of atoms and subatomic particles. Proponent: Erwin Schrödinger was born August 12, 1887, and he won Nobel Prize in Physics for his discovery and his atomic model. Here are the limitations of quantum mechanical model of an atom. The advantage of this model is that it consists of mathematical equation known as wave function that satisfied the requirements placed on the behavior of electrons. The disadvantage of this model is that it is too difficult to imagine a physical model of electrons as waves. Although life is full of uncertainty, do not be discouraged and think positively. Quantum mechanical model of atom. There you go, ladies and gentlemen, the different models of atoms. What an amazing presentation of the different models of atoms. We would like to hear your voice about the different models of atoms presented to you a while ago. Vote online and let us know which model do you think is the best to explain the properties of atoms. Kindly send your vote to your science teacher with the format that you can see in your screen. Your voice will only be valid once you pass this simple test. Read the following questions and choose the letter of the correct answer. We are glad that you participated in this historic event, giving importance to the scientific ideas that contributed to our understanding of the atom. I am Jemwel Dela Paz, your lead investigator in this case 3.3 entitled Atommodeling. Case closed. See you again in another episode of How to Be a Scientist, a journey where science is the key